Hi everyone, welcome to the second video in our series on trigonometry. In this video we're going to introduce the trigonometric ratios sine, cosine, and tangent. They are often abbreviated to sin, cos, and tan. And you will find these as buttons on a scientific calculator, and if you're using a CAS calculator, you'll need to dig into a menu to find them. So I'll just start my CAS calculator in the background and we'll get underway. So let's recap what was in the last video. We started by introducing the notion of a reference angle, theta. And this is a Greek letter. For a given reference angle, I defined the opposite side to be the side that was facing outwards from theta. And I labeled that with the letter capital O. The hypotenuse has not changed. It is still the longest side in the right angled triangle, and it is the side that is facing outwards from the right angle, and I labeled that H. The remaining side is the adjacent side, which I labeled capital A. And if I think of the angle as touching two sides, A is the side which is not the hypotenuse. So, now that we have this language, we are ready to define sine of theta, cos theta, and tan theta. If you go on in maths, you will define these in a different way, but for now, we're just going to be concerned with the ratios of side lengths in a right angled triangle. So, if I give you a triangle like this, here's how we define sine, cos, and tan. We're going to define sine as the length of the opposite side, O, divided by the length of the hypotenuse, H. So sine equals O over H, or opposite over hypotenuse. And just as a reminder, when I write a fraction, this means division. Okay. Next, cosine. I'm going to define this to be the adjacent, capital A, over the hypotenuse, H, and tan, we're going to define it to be O divided by A. If you're going to go on and use trigonometry, whether this be in advanced mathematics, construction, or electrical work, you will want to have these memorized. You don't want to be looking these things up. So a way that students remember this is with the saying Sokotoa. So perhaps you can see where this is coming from. Sine is opposite of a hypotenuse. Cosine is adjacent of a hypotenuse. And tan equals opposite over adjacent. So the S, C, and T stand for sine, cos, and tan, respectively. One thing that I should also add is sometimes people refer to these as sine, cosine, and tangent. Okay. I know it's a bit abstract because there are no numbers on this slide. Keep this definition in mind because now we're going to write down sine, cos, and tan when we are given the numbers in the right angled triangle. So let's do a few examples. What I'm asking you to do here is to tell me sine theta, cos theta, and tan theta when I have given you the triangle. So let's do part A. Here's our angle theta. If you're starting out, I suggest you label the opposite, adjacent, and hypotenuse. So if I just quickly note that these are right angles, the opposite side is facing outwards from theta. So O is going to be 3. The hypotenuse is facing outwards from the right angle, so H is going to be 5, and A is going to be 4. So sine theta, if you've already forgotten, remember, SOHCAHTOA. That is, sine equals opposite over hypotenuse, and that equals 3 divided by 5. Cosine of theta is the adjacent side divided by the hypotenuse. So here's A, here's H. So it's going to be 4 divided by 5. Tan theta is opposite over adjacent, and that's going to give me O divided by A. That is 3 divided by 4. And that's it. If you want to, you can write a decimal, but fractions are acceptable, and I would say fractions are preferable as well, because there's no need to type them into a calculator, find an approximation, and then round them. So let's do this for 2 more triangles. Notice here, in part B, theta has moved. It is now in the top right. So I can't just copy O, A, and H and put them in the same position here. Because now, the side that is facing outwards from theta is down the bottom. So, sine theta is O over H, and that gives me 12 over 13. Cosine A over H is 5 over 13, and tan theta is opposite over adjacent, and that gives me 12 over 13. All right, one more. Here's our angle theta down the bottom. What we want to do is label the sides. So the side that is facing outwards from theta is 33, so that's going to be O. The hypotenuse is facing outwards from the right angle, so that's 65. And that should be obvious because the hypotenuse is the longest side. And that's clear once we've got numbers in the triangle. Lastly, A is the remaining side. So sine equals opposite over hypotenuse, and that gives me 33 over 65. Cosine, adjacent over hypotenuse, 56 over 65. And tan, opposite over adjacent, which gives me 33 over 56. So there we are. We have now got a definition for sine, cos, and tan. And now that we have this, in the next video, we will calculate some side lengths. See you then.